So I've been a research entomologist with USDA ARS since 2006. And when I first started, exotic ambrosia beetles were identified by the ornamental nursery industry as problematic insects. And so we've been working to address that issue since then. So my perspective will really be coming from that cropping system. But I'm just trying to give some overview today. Uh, really, bark and ambrosia beetles are types of specialized weevils. So they're in the family Curculionidae, and then you have the bark and ambrosia beetles within that family. And so, due to their wood-boring behavior, their wood-boring lifestyle, they are commonly intercepted at ports of entry, one of the most common insects to be intercepted. And so in terms of bark beetles, you have the females and males flying, and either males or females can initiate attacks on trees, and then you mostly have sexual reproduction. In the case of ambrosia beetles, the males are flightless. And so it's the female that's initiating attacks on trees. You then have the female tunneling in, which I'll discuss more here in a few minutes. And so the female can then produce, if she has not mated, the female can then produce through haplodiploid reproduction. And you then also have sibling mating. And so these biological parameters really make ambrosia beetles, unfortunately, very successful invaders. And so, as I mentioned, you really only need one female to start an infestation. And so it really results in these beetles being, unfortunately, very good invaders. So there are 30 non-native species of ambrosia beetles in North America, a lot of morphological diversity, as you can see here. Several of these species are considered significant pests in tree crop horticultural systems, but also in forested systems. And so, of course, today, the focus is on the Mediterranean oak borer. So, as I mentioned, these are wood-boring insects, and so you can see here the female has landed on a tree. This is Zalacandrus germanus, a species that is especially problematic in the eastern U.S. And so she will then, if she receives the right chemical cues, she will then start tunneling into that tree. And if you look at a time lapse over about 24 hours, you have the female tunneling into the tree. And so in terms of symptoms of ambrosia beetle infestations, I'd say one of the classic symptoms are these noodle-like structures that will occur as a result of the female tunneling into the tree. So she's not consuming the wood, she's just tunneling in and then pushing the wood back out of that tunnel. So in the case of Zalacandrus germanus, again, a species that we've worked with quite a bit, the diameter of the tunnel entrance is about 1 millimeter, whereas for Zaloporus monographus, it's a little bit larger than 1 millimeter. And so there has been some work by Davide Rosati that's demonstrated that you can actually differentiate among species based on the tunnel diameter. So in terms of horticultural tree crops, what we've seen, in addition to the noodles, also the sap production that occurs, and then, of course, the branch dieback. So what's happening once they're inside? As I mentioned, the females are not eating the tree, or the adults or the larvae. They're actually fungus farming insects. So the female will tunnel into the tree, and she will then transfer spores of her fungal symbiont or mutualist. And once that fungus is growing, she will then lay eggs. And so there are several examples of that here. And so you can see the fungal symbiont growing on the tissue walls, and the presence of eggs and offspring. And so they must consume this fungal symbiont in order to properly develop and reproduce. So these ambrosia beetles have a specialized structure that allows them to carry spores of their symbiont. So this seen here is the most highly specialized version of that of that organ, and it's referred to as a mycangium. And so this is a thoracic mycangium. So if you were to longitudinally section this Zosandra germanus beetle, this female, you would see a pouch, and contained within that pouch are spores. And in the lower left here are images of that the mycangium full of spores that is associated with dispersing females. So there, in addition to the thoracic mycangium, there's also an oral mycangium, and that's the type that's associated with the Mediterranean oak borer. And so, as you can see here on the left, the mycangium can be located in a few different places on these ambrosia beetles. But in the case of the oak borer, it would be an oral mycangium, like in caption F here. So in terms of the mycangium, in terms of the fungal symbionts, I should mention that these do not exist as free-living species. They are only associated with these insects, so they rely on the ambrosia beetles for transport. The associations can range from general to the specific, depending on the species. Raffaella and Fusarium species have been identified from Xyloborus mesographus, and obviously there'll be more discussion about that in other quick talks. Most of these fungal symbionts are not pathogenic, but there are some that are highly pathogenic, including the symbiont associated with the red bay ambrosia beetle and the Polyphycus shottle borer are also both considered pathogenic. So in terms of their preference for trees, there's really a range of host quality that we see. So in the case of the red bay ambrosia beetle or Polyphycus shottle borer, those insects are known to be infesting and specifically attracted to and infesting healthy trees. Whereas the species that we work with in ornamental nurseries and apple orchards, those species are focusing on stressed trees, so trees that are weakened. And then, of course, you have species that focus on dead host material. As you can see here, you have sawdust that's being produced from infestations on this log. And so from what I've encountered so far in terms of the literature, it looks as though the Mediterranean oak borer is preferentially infesting stressed trees. And so understanding that association is important, because that would then influence management practices in terms of whether it's to understand what role host quality is playing is an important component. So two species that we've, again, focused heavily on, Xylosandra germanus and Xylosandra crassularis, both introduced quite a long time ago, but have since spread quite rapidly and established in much of the U.S. And so these particular insects are, as is the Mediterranean oak borer, they're strongly attracted to ethanol. They've been certain species of ambrosia beetles have been identified or determined to or demonstrated to infest gasoline canisters associated with ethanol. But of course, if you're sitting out in your patio in the spring having an adult beverage, you'll often see ambrosia beetles showing up. And so, in terms of ethanol, ethanol is a stress-induced compound. And so, when a tree is deprived of oxygen, it will switch from aerobic respiration to anaerobic respiration. And ethanol is a byproduct of that anaerobic respiration. And so, ethanol is emitted due to a variety of physiological stressors. And the important thing to realize here is that it can be induced very quickly in response to those physiological stressors, and that the trees can appear apparently healthy, but in fact be under stress and signaling their vulnerability to ambrosia beetles. So what we've seen from ornamental nurseries is that despite a broad host range for these species of the exotic species that we focused on, despite a broad host range, they're attacking specific trees that are associated with that have been subjected to stress and are emitting ethanol. And so it's not a random distribution, but in fact, they're targeting specific species and specific individuals that are stressed. So flood stress has been a really important component that we've identified as predisposing trees to attack by opportunistic ambrosia beetles. We have not found drought stress to induce attacks at a substantial level. Sometimes we see a couple attacks here and there, but it's in terms of as you can see here on the y-axis, number of tunnel entrances per tree, and time after field deployment on the x-axis. 80 attacks per tree on flood stress trees, but drought stress trees, we just don't see these particular species. Now, in the case of Mediterranean oak borer, it could be a different scenario, but I just want to point out that these are things to keep in mind. We do also see that low temperature stress is problematic in ornamental nurseries and tree fruit orchards in terms of predisposing those trees to infestation. This type of stress results in ethanol production, and beetles are then specifically targeting those trees. Now, ethanol is an important attractant for these ambrosia beetles, as you probably guessed, and so the ethanol can be used in a variety of ways for monitoring purposes, whether it's commercially available lures. Stem sections can also be soaked in ethanol. You can also core and fill stem sections with ethanol. And you can even inject trees with ethanol. And that also results in heavy attacks. And again, that can be useful for research purposes, and some of these techniques can also be used for monitoring, but also evaluating chemical control options. So again, there'll be more details, I'm sure, related to this. So I just wanted to point out that in terms of the number one lesson that we've learned in terms of these types of opportunistic ambrosia beetles is to maintain tree health. And that's becoming more and more challenging due to extreme climatic events. But in our experience, for the ambrosia beetles that specifically are targeting trees that are stressed and emitting ethanol, a number of studies have demonstrated that these beetles are not targeting healthy trees, and that if you can maintain tree health, these beetles are not viewing those trees as suitable hosts. And so I just wanted to point out that we have a NIFA SCRI project addressing these exotic ambrosia beetles in these cropping systems. And so not related, I mean, somewhat related in terms of their host selection behavior to the Mediterranean oak borer. So just wanted to mention that if you have some interest in learning some more about these insects, feel free to visit stopab.org. And so with that, just like to acknowledge some funding sources and collaborators. And with that, I'd be happy to answer any questions.